Today we're going to be talking about derivatives of inverse trig functions. More specifically, we're talking about the derivative of inverse secant. So the formula that I like to use for inverse secant is basically um, I take the derivative of this u component and put that on the numerator, and then the denominator is just the absolute value of u times the square root of u squared minus 1. I like to do it this way because I break it down to components and I just plug it into the appropriate component and I just do algebra. That's easier for me. That's how I always done it. That's why I like to use this formula. This is a more common one. It's 1 divided by absolute value of x times the square root of x squared minus 1. And you can use this also, same exact thing. And I will prove this formula later in the video. Let's do a example first. So if we take the derivative of inverse secant to the x squared, what do we do? First, let's find our u component. Our u component right here is listed as x squared, and we just put that right there. Next, let's find our u prime component, and derivative of x squared is what? 2x. We have a u prime, we have our u. What do we do? Put it back into the equation. Our u prime is 2x. Our u is x squared. Our u is going to be x squared, square that, minus 1. Just to make it a little bit more cleaner, we're going to square x squared again. And the final answer should be 2x divided by x squared times the square root of x to the fourth minus 1. That's an example of how we can use the formula. Next, let's prove the other formula, which is 1 divided by absolute value of x times the square root of x squared minus 1. This is proof of the derivative of secant, inverse secant of x. First things first, let's make y equal to inverse secant of x. We take secant on both sides, and we have secant y is equal to x. Now we'll take derivative with respect to x. The derivative of x with respect to x is 1. The derivative of secant of y with respect to x is going to be secant y times tangent of y. And because it's with respect to x, we have to factor in the y, and we'll get y prime. We'll put everything to one side, and we'll get y prime is equal to 1 divided by secant of y times tangent of y. But how does this equal this? They're essentially the same thing, but how? I'll show you the next slide. If we make a right triangle and we use the formula or the equation x is equal to secant of y, we get this right triangle. All right. Using Pythagorean theorem, this is supposed to be an x. This is not the Greek letter gamma. Is it gamma? I don't know what it is. But yeah, this is not. It's supposed to be an x. This is atrocious handwriting. I apologize. Yeah, so this is what we get if we make a right triangle. We get square root of x squared minus 1. On one side, we have 1 on the adjacent side, and then we have the hypotenuse as x. But this still doesn't tell us how does this relate to this. Next page. So, secant is defined as hypotenuse over adjacent. Hypotenuse is what? This is our x. Adjacent is what? 1. So we just put this. X over 1. Tangent is defined as what? Opposite over adjacent. That's the square root of x squared minus 1 divided by adjacent, which is 1. There we have it over here. So we would just put these values back into this equation we derived, and voila. This gives us a formula. 1 divided by x times square root of x squared minus 1. Thank you for watching the video. Please like, comment, subscribe, and have a great day.